Right, so inverse functions, we're going to approach it probably algebraically. You've probably seen it. You might have seen tables. I don't know if you've seen the graphs of inverse functions before. So I would start with kind of the easier stuff. Then you move to the algebra, and then I'll show you a graph and how you figure it out with a graph. Okay. Sound good? So I'm going to give you a function in a table format. Basic linear function. How do I figure out the inverse? Anybody know? Any see what? Okay, so no, it's much easier than that. An inverse function, you just switch the x's and y's. That's all we're doing. So in the inverse, that's all you're doing with the table of the points. If you have points, okay, like -1, 3 is on F, right? 3, -1 is on the inverse. Okay. The big idea is switch the x's and y's. You're going to see it in the algebra too. You're going to see it on the graph. That's what an inverse is.
You can put signs out, or you
No, you just straight switch them. That's it. If I was to draw a graph of it, I'm just going to do this one point. Oops, that's not it. Getting up at 4:30 this morning did not help me. My brain. By the way. Okay, right there, correct? 3, -1. We have reflected this. This is how you geometrically figure it out. You've reflected it over the line y equals x. That's what this is. Okay. So it's a reflection over y equals x. So we've been working with the x-axis and y-axis, right, with parent functions. Yeah. Well, now it's the diagonal. You can see that this distance and this distance should be the same, and we're perpendicular to that. Okay. So if you have to just tilt your head, I guess. That's all an inverse function is. Okay. Numerically, you split the x's and y's. Graphically, you reflect it over the line y equals x, which is the same thing as switching the x's and y's. Algebraically, do you remember how to calculate an inverse? Not quite. We will be multiplying, but not yet. Okay, so to calculate the inverse algebraically, we have to like 3 or 4 steps. Right, so the first step is to set what is equal to y. So we plug y in for f of x. They mean the same thing, but f of x is just more powerful language mathematically, so we like to use it now. Swap. There we go.
I just say I. If I'm interested in
I went from Roman numerals to English. So there's your swap x and y, right? That's what an inverse is. You're switching x's and y's. Switch them. That's what we did in the table. That's what we did in the graph. So same thing, we're just doing it in a different format. And now solve for y. So subtract 3 divided by 2, right? When you divide this over, you can put it in both terms. So you see the slope and the intercept easier if you want. And then write it as a function inverse. That little -1 there tells us inverse. There are times when people get confused and say it's f to the -1. You'll never see that. But it's definitely an inverse of this -1. It's a notation. So that's our inverse function. Right? I'll show you the graph. So the first one. There's f, right? F inverse is going to be a reflection over the line y equals x. So you can graph it, do it algebraically, it's fine. Or you can just do it from the graph. So this, they cross this line right here, so we know they're going to intersect right there. This point is 0, 3. So the point here is going to be 3, 0. Yeah, let's switch them. 0, 3, and 3, 0. Okay. This one's about at 1.5, correct? On the x-axis, or -1.5, so we're going to have something around -1.5 on the y-axis. Yeah, those are switching there. Okay. So your inverse is going to look something like this. They will always cross at the line y equals x. Okay. You can write that down. We'll use mathematical order for this. We will intersect on y equals x. Always. They might intersect again if you have a quadratic or something. So that's how they work. So algebraically, you can do it graphically as well. So those are kind of the easy examples. You get the big idea?
Yeah.
Switch the x and y. Okay? Doesn't matter if it's a graph, a table, or a function. Let's look at some more difficult ones. Like the quadratic. Don't hide your emotions, Sean.
I'm doing it for now.
Oh, okay.
At least I'm a bit this time. Last year, I said,
If you're given a function, you're asked to calculate G inverse, that implies that we want the function. We want to do algebraic. So, first step, plug y in. So we're going to do y equals. Good. Now we're going to switch them. And solve. So what do I do this step? Yeah. Is this correct? You can say no because I asked. Huh? You have to include a positive or negative. When you take the square root of the square, in here it could be negative, correct? You need to, but the square makes it positive. So when there's no square here, we need to account for the fact that could be a negative number. So we have to include the positive or negative here. Actually, if you want to get technical, the square root of the square is the absolute value. The absolute value, when you solve an equation, you have a positive and a negative case. So that's what we're taking care of here. So we're going to have G inverse. Positive or negative root x plus 5 minus 2. That is our inverse. So if you're working with a square, work to the fourth, work to the sixth, any even power, remember this. This is with even exponents. With odd exponents, I don't need to worry about it, because they can give you negatives. What's the cube root of negative 8? Not 2. Negative 2. Okay, so negatives can come out of odd exponents. Negative 2 times negative 2 times negative 2. Negative 8, right? So we don't have to worry about this with odd exponents. Just with the evens. Okay. Keep that in mind. All caught up? Okay, let's graph these. I want to show you. There will be a question. Is G inverse of x a function?
No.
Why not?
Because it,
Exactly what it is. All right, let's graph G. So left 2, down 5. G inverse is down to left side. Right? Is that right? -2, -5, -5, -2. Yeah. It should look something like this. My graph is probably not perfectly accurate. Just a sketch. Is G inverse function with, does not pass the vertical line test, right? So this is not fine. Doesn't pass the vertical line test. Oh, I didn't take it.
trying to teach
Yes, ma'am. Galileo Garcia. Yep. Uh-huh. Okay. Thanks. It's funny, she doesn't do that very often. There must be something pressing happening. They do this about half the time. Okay, so it's not a function. Can you look at the original without the inverse and tell me if the inverse is a function or not? You can. You know how it is.
I don't know what to do. We just like it.
If you picture the inverse,
Yeah.
I'm saying if you don't picture the inverse, if I just have the black, can I say yes or no, the inverse is a function?
Based on the same class.
Yeah.
Yeah,
Anybody
you're
else?
not within a function, then that is one to
Okay, that pattern does not hold. It's a good thought. On quadratics, it does. Okay. Yeah. If g of x does not pass the horizontal line test, so if we do a horizontal line, does it pass that twice? Okay, so it doesn't pass the horizontal line test. That means g inverse is not fun. It's not a function. So you can see how that translates to be a vertical line in the inverse, so it doesn't pass. The inverse does not pass the vertical line test. If the original does not pass the horizontal line test. And that's a function of the reflection over the y-axis. Okay. So you don't even have to look at the inverse to know that it's a function or not. Is f inverse a function? And yes, it is, because it passes the vertical line test, right? The original passes horizontal line test, so we know the inverse is a function that way too. So if you know the graph of the original, you can tell me if the inverse is a function or not. A function proper for every x there's 1, 1. Okay. Got it? I'm sure you do. Okay, let's do a harder example, and then we'll be done. That one's pretty easy. The harder one here somewhere. If you gander the exercise and then well, I guess we could do a root function. How does that sound? Then you just want to be done. Let me do one more, just real quick. This for you, Sean. Yay. So thrilled. So thrilled, in fact. Putting it all down. Remember all of it, right? So if that's our function, and it is a function, what does it look like? Just what's the paragraph of the cube root? Anybody remember? That's a cubic. Cube root looks like this. Look, look like it's the inverse of the cubic. Oh, yeah. So this is the cube root of x. This is x cubed. They're inverses. So is the cube root of x a function? It is. And x cubed is also a function. So let's do algebra here. X, so this is step 1, it's already done for us, basically. Step 2, swap the x's and y's. Oh, yeah, x minus. Two. Root of 7. X minus 2 cubed equals y plus 7. And so our inverse. You might notice the inverse somewhere because we don't put y to the -1 or anything on it. That -1 is reserved for function notation, so you might just make it up there. Inverse. Any questions? That'd be weird, I thought it was really weird. Okay. Sounds good. The silence is sounding good. Lots of individual problems here, but there's no more than usual. No. Yeah, they're all just individual problems. If you want, I can just assign up to 53 all. No. I look through these assignments and I look at every single problem and I pick them specifically. So, these are the ones I think that are best for you in the practice. Get ready for one to learn the material and do the practice for the test. We got 20 minutes, so enjoy.